Research on signal processing leads to a new Internet of Things technologies and applications. BI Business Intelligence predicts 22.5 billion IoT devices by 2020. Signal processing plays a significant role in expanding these IoT device numbers in the world. Signal processing to support new IoT services to make it much more less expensive. Hello and welcome to Educational Article Review. I'm Kiruthick Raja, registration number 19BEC 7028 from the School of Science, doing my BTech second year at VIT Amaravati campus. In today's video, we are going to review a special report, a magazine article written by John Edward, published in IEEE Signal Processing Magazine, September 2018, titled Signal Processing Opens the Internet of Things to a New World of Possibilities. BI Business Intelligence predicts 22.5 billion devices by 2020 compared to 6.6 billion devices by 2016. Signal processing is going to play a significant role in expanding these device numbers. First, starting with up in the air. It has been stated in the article that researchers from MIT have developed a system that allows small drones to read RFID tags with a tens of meter range and an average of error measurement in centimeters. Their envision is that this could be used in a large facility for continuous monitoring to prevent inventory mismatch and pinpoint the location of each item so that employees can rapidly meet customers' requests. RFIDs are wireless, battery-free electronic barcodes. Generally, we see barcodes when we go to stationery shops and other supermarkets where the barcode will be scanned by a reader, but it is just a sticker pasted on it. But this RFID is an electronic version of a barcode, which costs up to 60 rupees with the capability of wireless charging from its nearest reader. That is, the drone which is flying in the particular point is the nearest reader, and this RFID tag gets its charge from the drone. RFly, the small drone that is being developed by MITians, can be readily integrated with today's RFID infrastructure without the need of hardware and software modifications. It is said that it leverages the continuous drone flight path to emulate a virtual antenna array. So the location of a RFID tag can be accurately pinpointed with an error smaller than 20 centimeters, even if an RFID tag is 10 of meters away from the readers. The localization capability of RFly allows you to not only identify but locate misplaced items. We leverage frequency shifting, Windows function, and bandpass filtering to cut the feedback loop of the self-leakage path in a relay circuit to avoid oscillation, and that allows greater signal amplification, MA. And researcher from MIT explains. He has also mentioned that they use matched filters to boost the signal-to-noise ratio in the process of extracting signal amplitude and carrier phase. They have also mentioned that they harness the synthesis aperture radial equation in the process of calculating the RFID tag location using a mobile drone. They observe that the project's algorithm go in hand with circuit design. They mentioned that a system presents a unique hardware-software cross-layer optimization which allows us to achieve much better performance. Therefore, the algorithm capability to the hardware is the most important consideration. As they make their own hardware and software together, the cost also goes very less expensive. Because the drones today limit to the payload and the battery capacity, weight and power consumption were also key design considerations, because as you have seen, the load which is being needed for the thrusters is equal to twice the weight of its own payload. Overall, it's important to keep the choice of signal processing approach concise and elegant. Whenever there is a new product being made by a company, they have to test it and trial it. What is the importance of testing then? Testing essentially helps you save time, money in a long run because issues are resolved before bigger problem occurs. The maintenance costs are also lower, and in the end, if the product works 100% as it should, no exponential damage is done to your business cost-wise. That is the importance of testing, which is being done by all the companies before releasing a product. All these experiments on RFly have been conducted in Media Lab involving target objects, many intentionally hidden to approximate the condition of merchandise heap in pile of warehouse shelves. The system was able to localize tags within 19 cm accuracy while extending the range of the reader tenfold in all directions and 100-fold cumulatively. In this section, I would like to conclude what we have seen. We have seen RFly, a technology, a small drone capable of reading RFID tags, has been invented by MIT researchers. And now, in the second section, we are going to see about going underground. According to the Colorado State University, US alone has 13,000 active mines for extracting minerals and other natural resources. Keeping diggers safe and productive is a significant task given the way that radio signals can infiltrate deep underground. So an undertaking drove by college engineering experts took off to give an excavators a low-cost, high-fidelity communication system that bypassed global positioning system GPS, wireless, cellular, and other signals that are taken granted for above ground. In the past decade, mine accidents have killed 40,000 mine workers worldwide, 500 of which were in United States alone. Unfortunately, the high cost of deploying a safety infrastructure encourages the companies to meet only the minimum requirements safeguards. Mining safety demands a scalably low-cost solution to enable sensing, communication, and tracking in underground mines to direct precursor to mischief, and also aid rescue efforts in the aftermath of an accident such as tunnel cave-in or an explosion. This project's wireless cyber-physical framework incorporates standard smartphone and low-cost wireless sensing. It aims to eliminate the need of expensive handheld and communication equipment and give miners an extra edge for safety, whether for day-to-day communication or during emergency. What is this cyber physical? Cyber physical systems (CPS) are integrated of computation network and physical resources, embedded computers and network monitors, and control the physical processes with feedback loop where physical processes affect computation and vice versa. These researchers' planned framework offers a wireless network consisting of multiple low-cost stationary ZB or Bluetooth sensors deployed strategically throughout a mine, creating a mesh network that can connect a smartphone with carried by the miners. The precious placement of the fixed sensors are based on the analysis of how radio signals travel in an underground mining complex, changing when connected to a wireless mesh network. The researchers believe that the system will be able to accurately and efficiently calculate the miner's location within a mine despite the high unpredictable nature of wireless signals. So what is unpredictable nature of wireless signals? When I was searching in Google, I found this one particular paper explaining the reason for this unpredictable nature. This paper was written by Vijay K. Gar in Wireless Communication and Networking in the year 2007, titled Radio Propagation and Propagation Path Loss Models, and it has been released in Science Direct. He has written about characteristics of wireless channels in his paper. He has mentioned as the wireless channel is much and more unpredictable than the wireline channel because of the factors such as multipath, shadow fading, Doppler shift, and time dispersion or delay spread. These factors are all related to variability introduced by mobility of the user and the wide range of environment conditions that are encountered as a result. Multipath delay occurs as a transmitted signal is reflected by objects in the environment between the transmitter and the receiver. These objects can be buildings, cars, hills, even truck, etc. Coming back to our topic, determining the heading angle, the angle a user is facing with respect to true north is obtained by combining accelerometer, gyroscope, and magnetometer readings. The accelerometer provides the gravity vector, the magnetometer functions as the compass, and the gyroscope provides angular rotation speed. Angular rotation speed data signals are integrated over time interval to determine the orientation of the mobile phone. All these data are used to determine the change in position from a current position. In a similar manner, we can use various signal processing approaches to combine the fused integrated sensor data within wireless signal data to locate a user. But what are the problems being faced when doing this? So how did all this started? When I more read on it, I found, for instance, when simulating an underground mine, we first required a digital representation of the tunnel system in the form of a triangular mesh. Since mine tunnels are very large and asymmetric, hand measurements and manual mesh buildings are out of question. Instead of using this, they use LiDAR sensing to collect millions of measurements of the mine in the form of point cloud data. What is LiDAR instrument? The LiDAR instrument fire rapid pulse of laser light at a surface, some at up to 150,000 pulse per second. A sensor on the instrument measures the amount of time it takes for each pulse to bounce back. By repeating this in a quick succession, the instrument builds up a complex map of the surface it is measuring. However, these data are noisy and only represent a discrete set of examples for a continuous object. The data also doesn't provide any detail regarding the scanned surface, normal vectors, or what the surface may look like between two sample points especially. The research group have therefore went on to signal processing techniques like principal component analysis, to extract properties like local curvature and surface normal from the point cloud data in a way that is very tolerant of noises. So that is the end of the section 2. We started the discussion on the importance of safety for miners, and then we spoke about cyber physical framework. Then we spoke about the unpredictable nature of a wireless signal. Then we spoke about how accelerometer, gyroscope, and magnetometer are used to find the location of a user. And at last, we spoke about LiDAR instrument. And at the end, we saw how the research group members finally found a way to find the measurement. So moving on to the third and final section of our educational article review. Third, a new foundation. At Finland, Aalto University researchers are addressing two key IoT challenges. These two challenges are not only meant for IoT. Whenever it comes for an electronic engineer, these two challenges are always a big question mark. And the first challenge is device size and the second challenge is power consumption. When they were asked on why they were addressing these two challenges, they told that to make everyday IoT tags and sensors smaller and less power hungry, because IoT will soon require capability to process and store unmatched amount of data, resulting in a huge energy cost. Moreover, current CMOS technology will soon be unable to undergo further minimization in size because the CMOS is already very small. Their view is as viable and superior approach to replacing the transistor with a memory resistor, a memristor. It is a two-terminal resistor switching device that can retain memory of its last resistant state even after being powered off. This analog control of various current conduction state offers the opportunity of mimicking the human brain-like activities, which is the goal of neuromorphic computing. What is neuromorphic computing? The idea of neuromorphic computing is to take inspiration of brain for designing microchips that merge memory and processing. In the brain, synapses provides a direct message access to the neurons that provide information. This capability promises the lead to a new generation of intelligent IoT devices. Memristor. What is a memristor? Let us go a bit detailed on what memristor is on the details which I found in Google. This device, a nanometer thick ferroelectric thin film squeezed between a pair of electrodes, can function with voltage of under 5 volts. The technology is capable with a wide range of electrode materials, including silicon, and can be manufactured in conventional production facilities. Tunnel junctions also offer the benefit of being to retain data for over a decade without requiring a power source. This is very similar on how human brain processes information through electric impulse. Therefore, the research group believes that this device is very suitable for neuromorphic computation. A key that IoT need is ample data storage and processing at an affordable energy cost. Memristor-based neuromorphic circuitry can provide a solution in this respect. This has already been proved by V.G. Zhang, author of Design of Neuromorphic Circuit based on memristor, which has been released in ResearchGate. The researchers are now working to take the technology to a higher level. When they were asked what is the higher level on this device, they stated that what we are striving for now is to integrate million of our tunnel junction memristor into network on a 1 centimeter square area. We can expect to pack so many in such a small space because we have now received a record high difference in the current between on and off state in the junction, and that provides functional stability. The memristor could then begin performing various kind of complex tasks such as image and pattern recognition, and even make decisions automatically. And now I would like to recall what you have seen in this third section, a new foundation. First, we have started with the problems that we will be facing in the future by using CMOS technology. Then we saw about what is neuromorphic computing. Then we went on to what is memristor and the usage, how it is being used. And then we have seen a proof on this memristor based neuromorphic circuitry. And we have ended with what is the future of this. As this article ends, I believe that you would have learned something new in this educational article review. On my personal interest on the search on this paper showed me that this is a follow-up report on signal processing leads to new wireless technologies written by John Edward, published by IEEE Signal Processing Magazine, August 2014. Mr. John Edward is a technology writer based in Phoenix, United States. 36 of his write-up has been published by IEEE Signal Processing Magazine. Meet you soon with another great article to be reviewed in Education Article Review. Stay tuned on our updates by clicking the subscribe button and by pressing the bell icon. For more information, Google thicknesslc.com or write us at thickness.learn@gmail.com. Thank you.